We are taking this from the September 2015 from the Western Cape. Question 8. A cell with an unknown internal resistor is connected to 3 identical light bulbs. Each of the resistance is 2 ohms and a high resistant voltmeter V, a low resistance ammeter, and a switch S is shown below. So this part of the battery is the positive and that's the negative. The total current will flow in this direction. So an ideal voltmeter has a very high resistance, or it has infinite resistance, so it allows very little or no current at all to flow through it. So no current will go in this direction even though this is a junction. So the total current will still flow this way. And when the current gets there, it will be divided. You will have I1, and then in this direction you will have I2. The current will flow all the way to this point, and then it will combine again to form I total. When switch S is open, the reading on the voltmeter is 6 volts. So that is the value of the EMF. When no current flows in the external circuit, this voltmeter right here will register the value of the EMF. Because when switch S is opened, there's no current that's flowing in the external circuit. So EMF is equals to 6 volts. When switch S is closed, the reading on the voltmeter is 3.9. So when current flows in the external circuit, V external should be equals to 3.9 volts. 8.1. State Ohm's law in words. The current that's flowing through a conductor is directly proportional to the potential difference across its ends, provided that the temperature remains constant. 8.2. Which terminal of the ammeter is represented by point E? Write down only positive or negative. So E is on the right hand side, and on the right hand side we have the negative terminal of the battery, so that is going to be negative. 8.3. Calculate the total external resistance in the circuit. Okay, so let's focus on XY. XY are connected in series, so R of series should be equals to R of X plus R of Y, which is 2 plus 2, so that's 4 ohms. So now we'll have something that looks like that. And then this is the R series, and then this is R of Z. So these two are connected in parallel. So R external should be equals to, for a parallel combination, we take the first resistance and then we multiply with the second resistance, which is 2 all over the sum of the two. So I am getting 1.33 ohms. 8.4. Calculate the internal resistance R of the battery. Okay. The EMF should be equals to V external plus IR. So we do have the value of the EMF. We also have V external, but we don't have the total current and the internal resistance. In order for us to get the internal resistance, we must have the total current. So let's try and find the total current. So we know that the current should be I is equals to V all over R. Let's find I1. I1 should be equals to, So the series combination is connected in parallel to Z. This means that the voltage that will flow, the voltage that will be measured across the ends of XY should be the same as that will be measured on Z. So this is going to be 3.9, and then the resistance of the series combination is 4. I'm getting 0.975 amperes. So that's I1. For I2, the same potential difference, and then the resistance of Z is 2. 3.9 over 2, I'm getting 1.95 amperes. The total current should be equals to 1 I1 plus I2. This is 0.975 plus 1.95. So the total current should be 2.925 amperes. So now we have the total current. We can find the internal resistance. The EMF is 6. V external is 3.9. The total current is 2.925 multiplied by the internal resistance. So this is 6 minus 3.9 over 2.925. I'm getting 0.72 ohms. We can even try another method to see if we get the same answer. In 8.3, we calculated R external, and we also have V external of the circuit, so we can find the total current. We will say I total, this is option 2, should be equals to V external all over R external. V external is 3.9 and R external is 1.33 from the answer from 8.3. So this is 1.33. 3.9. So I'm getting 2.93, which is pretty much the same with what we got there. And then we'll just take this value and then substitute there. We should get the same answer. And then 8.5. Calculate the reading on A when switch S is closed. So if you used option 1, you already know that the current that passes at A should be I1. So the answer should be 0.975. The current through A. And if you did not use option 1, you can just copy this whole thing and then find I1. 8.6. If light Z burns out, how will this affect the following values? Write down increase, decrease, or stays the same. Let's clean this up. So Z burns out. So we remove Z from the circuit. The total current will flow in this direction. When Z burns out, no current will come this way. So the total current moves like so. Whenever you remove a resistor in a parallel combination, R external increases. R external increases, so the current decreases. From this formula, when the current goes down, V external should go up. So V external increases, V lost goes down. And then the value of the EMF and the internal resistance, they do not change. 8.6.1. The reading on the voltmeter V. So we know that V external increases. 8.6.2. The total EMF of the battery. This stays the same because we said that the EMF as well as the internal resistance, they do not change. 8.6 point, oh, it's 8.7. Calculate the reading on A after light Z burns out. R external is going to be equals to 4 because we'll just add X and Y because no current flows in this direction anymore. So the total current will flow this way. So we'll just add X and Y, and then we will use the value of the EMF doesn't change. The current is what we are looking for. R external is 4, and the value of the internal resistance doesn't change as well. So the current should be equals to I am getting 1.27 amperes.